Okay, this is day 2 of Trig Identities. If you haven't watched the day 1 video, the first lesson that we went over Trig Identities, I strongly suggest you go and watch that one first before this one, because in that video I talk about all of the different strategies and very specifically the different options that you have. And identities are tricky because everyone is different and there is no step-by-step method for how to prove them, how to successfully answer these questions. But I outline all of your options, all of the different things that you can do, and I talk about how the hard part is if you don't know which one is right, you end up hesitating and you don't know where to start, and so you just, I don't know, give up, or you don't know what to do, or you just end up doing nothing, or you always feel or you always lack that confidence that what you're doing is correct. And I talk to that, and really that is just part of it. You don't necessarily know what the right thing to do is. But when you break it down, there really is only a few things that you can do. And once you practice and get that experience in any specific question, there's often really only one thing that you can do, maybe a couple, but it really, you really can, in some ways at least, break it down into a series of steps and get much more confidence in the fact that what you're doing is correct. So I talk at length to that point in the first lesson, and I think it's really worthwhile going over that first. In this lesson, we're only going to look at 2 examples. They're both great examples. They highlight some trickier identities and some trickier strategies that you might have to use at times, and I'll try to break down why you might think of doing these strategies if you came across a similar question. The thing about identities is, yes, there is some work that you have to be able to do. There, some fraction work. Sometimes you have to know the different identities, like the Pythagorean identity. There is some skills that you have to have that way, but the biggest part of it, the most challenging part, is choosing what to do in any given step. And I think that both of these examples will highlight that, and I'll try to speak to why you might choose to do these steps that we're going to do that's going to help us solve these. And really, it's all about observation. It's all about noticing what you have and knowing what tools you have at your disposal and deciding which tool to use. Okay? So let's get into this first one. We've got a left side and a right side. One of the main ideas that we have, or that I often suggest that people keep in mind, is that you look at both sides and you decide which one is more complicated, and you start on that side. That's not clear in this case. There's no right or wrong about which side is more complicated. One side has a fraction, the other side doesn't, but it has some reciprocal ratios, so it's not super clear what to do. So, which side would you start on? When I look at this, I think to myself, well, the left side has a fraction, but it's not clear what to do with that. There's not really any clear direction to go with that. There's no squares, so I can't swap out any identities that way. And it's not clear to me at the first glance of what I could even do on that side that might help. So I would tend to lean towards starting on the right side. And the reason for that is I've got a couple of reciprocal ratios. I might as well just kind of swap them out and see where that takes me. I have no idea where that is going to take me, but I'll just try it and see. One of our strategies is to change everything to sine and cosine. We have more identities in terms of sine and cosine, and sometimes that just takes us down the right road towards cleaning things up and getting us where we need to go. All right, so that means I'm going to change cosecant to 1 over sine. And I'm going to change cotangent to cosine over sine. Okay, and there's already a common denominator. That worked out nicely. I'm not sure that's an indication of anything that I'm necessarily in the right direction, but that does make my life easier. So I'm going to add these together. That's another one of the strategies that we have, is when you have fractions, get a common denominator and add them together. It is worthwhile talking about, observing, pointing out that on this side I've got 2 things here, and I've still got 2 things there. And on this side, even though it's not one simple thing, it's one thing, it's one fraction. I do have just kind of one term on the left side, and I've got 2 terms on the right side. So adding them together, now that I have fractions, and whether I have a common denominator or not, I could get a common denominator and add them together, and then I end up with one thing. So already this does look more like the left side, just because I've got one single fraction in both cases. Okay, and again, really the reason why I chose to do that is because what else is there to do? It's always a good thing if you have reciprocal ratios, tangent, cotangent, cosecant, secant, to swap them out for the primary ratios for sine and cosine. And there's not really anything else I could even see to do there. And then once I've done that and put it together, I start to see how that actually looked like it was helpful, and it's probably the right thing to do. Now, the reason why I think that this identity is so interesting is because when I look at these, it's, again, really not clear what to do next. And this is a tricky observation to make, a tricky next step. And often the strategies of swapping things out for sine and cosine, swapping out Pythagorean identities if you've got squares in there, and dealing with fractions, those strategies on their own solve the majority of identities. That's often all you have to do, but in this case it's not. In this case, I could do that first step that we've done, and then look at this and say, well, there's no clear direction of what to do next. So another strategy that is not as common, but does come up from time to time, and this is a good example of that, obviously, is you might call it a force. So when I see that this has a 1 minus, so this has a 1 minus cos x on the left side, has a 1 minus cos x in the denominator. What if and the right side has a 1 plus cos x in the numerator? Once this occurs to you, you might realize that this is the right thing, because you might see a couple of steps ahead and realize that this is going to work out. And when you've done enough of these, and once we do this, we're going to see why this works out. And so it's not that far off to recognize that this is going to be the step that we need to do. But sometimes what you might just do is say, well, I need to have a 1 plus cos x in the numerator on the left side. So I'm just going to force it. I'm just going to go times 1 plus cos x over 1 plus cos x. And again, with identities, you may not know that this is definitely going to work, but it's a possible strategy. It's something to try. And when I look at this one, I don't see anything else that's clear to try. So to me, why not give it a shot? And the reason why this is going to help is on the right side, I have 1 plus cos x in the numerator. And no matter what happens on the left side, now I'm going to have 1 plus cos x in the numerator. So hopefully that will be a step in the right direction. Okay. So, there's all these other little things like well, how do I know if I should expand the sine x through the brackets or not? And I would tend to say don't yet until you see that it's a good thing to do. You may notice that, oh, you know what, if I expand through, it's going to accomplish this, and then you can do that. But if you don't see a reason to, it's often better to leave it. So I'm going to leave the sine x out front times 1 plus cos x as well. This has a 1 plus cos x just by itself on the right side, so I probably don't want to expand the sine x through. That's going to muck things up. Okay. On the bottom, I'm going to expand, and what we notice is this is a product of a sum and a difference. So it's the result of factoring a difference of squares, right? 1 plus cos x times 1 minus cos x, which is 1 minus cos squared x. And if you didn't notice that, then you could actually expand it and do the whole expansion, and you'd get the same thing because the middle terms are going to add to 0. And that's a strategy that comes up often, is recognizing that idea or that relationship of a difference of squares, right? And part of the reason why that's so useful is because now I have the Pythagorean identity, 1 minus cos squared x is sine squared x. So that difference of squares is something that we do see fairly often in identities. And now that sine x will divide out with one of the sine x's on the bottom, and look at that, we're done. So just quickly to go back over it and summarize, I hope you understand why I like this identity so much, and it really highlights some interesting things. Remember, we started not really having a clear idea of what to do. There's not really anything to do on the left side. On the right side, we've got some reciprocal ratios. So, you know, why not swap them out for sine and cosine? And we simplified the fractions in that case. But then again, it really wasn't obvious what to do next. And so this more rare strategy of sort of forcing things turned out to be the right thing to do. It's all about observation, and I would imagine a lot of people might think, okay, but how do I know that's the right thing to do? And as I've said over and over again, it's not really about knowing what the right thing is. That's not the way identities work. You don't always know that it's the right thing to do. It's a matter of observing and trying things, and when you get that experience, you will eventually get to a point where you say, well, I don't know that this is the right thing to do, but there's nothing else to try. This is the only thing I really even can do. So, you know, I might as well try it. And what you find is when you're in that position, it ends up being the right thing to do because it really is the only thing that you can do, right? So I multiply by 1 plus cos x for two reasons. One was I noticed that it was going to give me that difference of squares on the bottom, right? So that's one thing you might just get used to, that 1 minus cos x times 1 plus cos x is going to give you that difference of squares, or same thing for sine, obviously. So that's one thing that you might notice. But the other thing is that this has a 1 plus cos x on the right side on top. And so multiplying by 1 plus cos x is going to get me that numerator that I want. And sometimes you just kind of force it and just say, well, I need that on top, so I'm just going to get it on top and see what happens. Okay, so that's example 1. We'll do one more. And this is another one that I really like. It highlights a lot of good strategies. It maybe looks like a complicated one. There's a lot going on. The identity starts out with the left side and the right side not really looking anything like each other at all. And again, you might kind of say to yourself, well, how in the world would I even know where to start with something like this? And this is where those strategies come into play. I've got a tan squared here, but tan squared is not all that useful. Sure, I could change it to, maybe I could change it to sine squared over cos squared and do something with a Pythagorean identity there, but that's a little ways off, so I'm not going to do that yet. But generally speaking, I have a bunch of reciprocal ratios and I have tan. And so really my first step to me clearly is to swap all of these out for sine and cos. And all I can say is, even if you don't have that confidence that this is the right thing to do, it is in almost every case. And if nothing else, it's going to allow us to simplify things and manipulate things. And then we're going to stop and take a second look at where we're at after we've swapped everything out. And then we're going to have a better idea of what to do next. And sometimes it just works out itself, right? So this is, again, like I said, this is where you have to just have confidence in the fact that there are only a few strategies, and swapping out tans or reciprocal ratios for sine and cosine is going to be the right thing to do. If you have anything that's not in terms of sine and cosine, always you want to swap them out. Okay, that's just going to help. So you just have to have that confidence in that strategy. So tan is sine over cos. Now I'm going to swap out this tan squared. I'm going to do that first. So it's going to be sine squared over cos squared. And then, you could do this all in one step or in two steps. But because I'm going to end up with a fraction in the denominator, I'm going to change the 1 into a fraction as well to get a common denominator on the bottom. And again, that's just one of our strategies. That's just something that you basically always want to do. And that's how I knew that that was the right thing to do, or was noticing that I've got a cos squared on the bottom in that term. So I'm going to change that to cos squared over cos squared as well. So this ends up being sine x over cos x. Cos x over cos squared plus sine squared. So just adding those fractions with the common denominator. And again, I notice that that is the Pythagorean identity. So that's 1. So, that might lead you to think that you're going in the right direction. Okay, now I'm dividing fractions. This is sine x divided by cos x, all divided by 1 over cos squared x. So I'm going to flip and multiply. Over 1. And so one of these divides with that, and I end up with this being sine x cos x. So that was definitely not predictable from the beginning, that tan x over 1 plus tan squared x was going to work out to sine times cos. But I had that confidence in the strategy of swapping things out for sine and cosine and dealing with fractions with common denominators, and just working things out and allowing things to play out the way that they played out, and ended up with something pretty simple. And that's it. Now that side's done. There's not really anything else clear to do on the right side, so I'll swap over to the left side, and I'm going to do the same thing. I've got a secant x. I've got two reciprocal ratios, secant x and cosecant x. So I'm going to swap them out. And I am going to get a common denominator at the same time. If you do that in this step or the next step, obviously it doesn't matter, but I'm going to multiply this by cos x over cos x. I'll show that. So that way I'm going to have cos squared x in the numerator and then cos x in the denominator. So it's going to have a common denominator with the other term in that bracket. And I'll do the same thing with this one. So I end up with 1 over cos x minus cos squared x over cos x times 1 over sine x minus sine squared x over sine x. And that gives me 1 minus, so now I did this on purpose, right? I have common denominators in both brackets, 1 minus cos x over cos x times 1 minus sine x, sine squared x over sine x. And these are both Pythagorean identities, so that works out to sine squared x over cos x times cos squared x over sine x. Okay, and then again, because this is all multiplying, I can do one of these sines. It's sine squared x means sine x times sine x. We'll divide out with that. And one of these will divide out with that, and I'm left with a sine x and a cos x. And look at that, that is the right side. So again, to summarize this one, there was some swapping out for sine and cosine, and there was in both the left side and the right side, there was some fraction work that had to be done. And to me, this just really nicely highlights how those are the strategies that you just have to use, and you just have to develop that confidence and trust that that's going to be the right thing to do, and see how it works out. And as you're doing these questions, observe for yourself that it's not obvious when you start out using these strategies that it's going where it's going to take you, and that's just the nature of these problems. Is it's not going to be obvious necessarily how things are going to play out, but you have that trust in the fact that doing those strategies is going to be the right thing, and however it plays out is going to play out properly. So fraction stuff, swapping out everything for sine and cosine. We saw a little bit of a little trick here with sort of forcing things and looking at what we can multiply by that's going to help, and just kind of coming up with something creative to multiply by, right? But then also looking at that relationship of difference of squares and Pythagorean identities. And it really does highlight a lot of these two examples, highlight a lot of the different strategies that we're going to use when we are solving and proving trig identities.